Hey, and we are live. That was quite an energizing animation in the beginning, I think. Hello, my name is Anton Arhipov. I'm a developer advocate at JetBrains, and I have Sébastien Deleuze with me today here to talk about Spring Native. Hello, Sébastien.
Hey.
Hey there. So this is actually a live presentation, so we are keen to hear your questions. The questions are open in the chat. Please type them in. And while the presentation is ongoing, I will be noting the questions to ask them afterwards, after the presentation. And if we don't have enough time to answer them all, we will note them, I guess, in the comments to the video. They will be there down there if you are watching the presentation later after after some time, then the answers will be in the comments if we have enough questions. So Sébastien, the stage is yours. Good luck.
Thanks. So hi everybody, my name is Sébastien Deleuze. I'm a Spring Framework committer and I have been leading the Spring Native project for some time. And today we are going how to leverage Spring Native with Kotlin. This is a quick disclaimer because what I'm going to present is going to change. And I would like to start by a little flashback. So in March, the Spring team announced something pretty special. So it was myself, Andy Clement, Brian Clausel from Spring Boot team, Jens from Spring Data, Ria from Spring Security, and Dev Sire and a few others. We announced Spring Native Beta, meaning that we reach a new step in terms of quality, memory footprint for supporting the native platform of Spring. And we had a huge community feedback because a lot of people were waiting to be able to compile their Spring Boot application with GraalVM native and really a lot of feedback. So that was nice. But let's talk more deeply about what is Spring Native. Spring Native provides beta support for compiling Spring Boot application to native executable with GraalVM, and it provides basically a new way to deploy your Spring Boot application. You are not going to deploy an executable jar or a container with the JVM and your Spring Boot application. You are deploying a native executable that then runs extremely efficiently. I'm not here to say that native solves all the issues. I mean, JVM and native offer different trade-offs. So the JVM is super mature. It provides fast build time, good performances, and native really shines in terms of startup time, memory footprint, and I think it depends on your use cases. So typical use cases for the native platform are sustainability. If you want to run your workload on smaller and cheaper instances in the cloud, I think that costs less money. That's also good for the planet. So that's interesting. For Kubernetes, being able to ship a small native executable on a tiny operating system, but then in a container really makes sense. And for Kubernetes and platform like Knative, where you start containers as soon as there is some new request, being able to start instantly your application, your Java application makes sense, I think. Serverless is an obvious use case as well because of the instant startup capability. And for microservices, it's about solving the issue that you have basically your monolith, your big system. You try to split it into multiple microservices, but each microservices is running its own JVM, and it consumes quite a lot of memory when you deploy that on the cloud. So it's about being able to split your application, your system into multiple microservices while keeping small instances and cheap hosting. So in the Spring team, our goal is to allow developers to compile their Spring Boot applications to native executable with as few changes as possible. There are various challenges. First, on GraalVM side, so GraalVM is a project started, I think, 8 years ago by Oracle. It provides, amongst other things, the capability to compile JVM bytecode to native executable. On this native platform, some JVM features are not supported. Basically, you can't create dynamically bytecode or this kind of very dynamic thing. There is no class lazy loading. configuration is required for reflection, proxies, and resource access. JVM libraries are currently mostly untested on native. That's why on integration framework side, there is an effort to integrate native. Compatibility versus footprint, because I think the GraalVM native platform tried to increase the compatibility to reduce the differences between the regular JVM flavor and native. But when you want to increase this compatibility, sometimes you have some regression in terms of footprint. So it's a thin line. We need to find a trade-off with the GraalVM team to find the sweet spot between compatibility and optimized footprint. And last but not least, there is very long build times. So that's an issue. On Spring side, Spring is typical Spring Boot application are using annotation-based programming model. So it is using runtime reflection to process that, to analyze this programming model, and that require a lot of configuration on GraalVM side. API backward compatibility is also a challenge, because all the work that we have done is based on Spring Boot 2 and Spring Framework 5, and we don't want to break the compatibility. So basically, we had to do this Spring Native project without major architectural changes on Spring Boot and Spring Framework, and without breaking APIs. So that's a kind of challenge. So if you want to start using Spring Native and compile your Spring Boot application to native with Kotlin, your native journey starts on start.spring.io. There is now a Spring Native dependency that you can use. And if you select that from the website or from the IDE integration here for IntelliJ IDE, it will basically automatically configure your project in order to be able to build your native applications. So you don't have to read all the documentation to find the right configuration. There is two ways of building native executable with Spring Native. The first one is based on build packs. So I'm not sure if you already know build packs. Build packs are a way to compile, to deploy Spring Boot applications to container images. So it's already included in Spring Boot 2.5, and upcoming 2.6. Typically, it will transform your application into a container with optimized layer, deploy the OpenJDK that is required to run your application. It will deploy also your dependencies and your application bytecode. And what we have done with Spring Native and in collaboration with the Spring Boot teams and the build pack team is to add native support. So instead of creating a container that will contain the JVM and your bytecode, basically, it will create a container that will contain a very optimized operating system, very small, and just a native executable, no need for a full OpenJDK. So that's how that works. It produces a Linux container image, so x86 is supported, and ARM support is a work in progress currently. So this is typically what you will maybe use to deploy that to the cloud, to production. In order to work as a developer, you are most likely going to use native build tools. So native build tools started as a collaboration between Spring and GraalVM teams, and recently joined by the Micronaut team. Originally, the Maven plugin was directly integrated in GraalVM repository, but now it's living in this github.com/graalvm/native build tools repository. It provides both Gradle and Maven support for building your application, and it produces a native executable. No cross compilation because native image compiler does not support it. So if you are building on Linux x86, it will create a Linux x86 executable. Same for macOS, same for Windows. So concretely, for the native compilation, you are going to use Gradle goal like Gradle native builds, or at the left with build pack, you are going to use Gradle boot build image, and it will create at the left a container, at the right a plain executable. The same is supported obviously for Maven, just showing Gradle here, but both are supported. So it's a small application here. You see it takes some time. It takes a few seconds to to compile. For small application, it's less than 1 minute. For bigger, it's a few minutes. And you will see that at the right, so we have just a native executable, 30 megabytes that can be used to run your application. And at the left, with build packs, you have a container image that is deployed locally, and you can start it, and everything is included. So what is interesting is that in terms of runtime, it provides instant startup for your Spring Boot application. So here you see that this small application starts in 8 milliseconds, both in container or via native executable. But even for bigger application, we have Pet Clinic that starts in a few milliseconds. So that really scales, and that really allows to start any Spring Boot application in a few milliseconds. So I think that's interesting. In addition to the reduced memory footprint, we will see figures later. So we provide first-class support for both Java and Kotlin, and today we are going to focus a little bit more on Kotlin, but really we support the two languages. The current scope of what is supported, because we don't support yet all what start.spring.io provide as dependencies, for example. That's I think that's, yeah, long-term target is to approaching that, but for now we have initial support for actuators, a lot of Spring Data modules, Spring Webflux and Spring MVC are supported, testing, etc., Spring Cloud. So we are going to continue to increase the quality of the compatibility in the upcoming month. Like I said previously, GraalVM native requires some configuration, some explicit configuration for reflection, resources, proxies, etc. But typically Spring Native will generate most of this configuration for you, because if you have to craft this kind of reflect-config.json file for your whole application, you are not going to be super effective. So really, Spring Native is going to infer what is required to run your application on native. And if there are some missing bits because you need a special native image option, if you need to add reflection, resources, proxy ints for your application, or for some stuff that we don't support yet, you can annotate your add configuration or add Spring Boot application classes with those annotation, and that will automatically generate the related JSON ints for native image underneath. So it's extensible, and we provide also some programmatic endpoints to extend that in a more dynamic way. So let's talk about Kotlin more specifically. So it's interesting because Kotlin have this Kotlin/native platform, which is different from what we show today. So here today I'm really talking about using Kotlin/JVM, so the regular Kotlin flavor that you are using with Spring Boot. Plus compiling the resulting bytecode with GraalVM native, which is this native-image compiler provided by the GraalVM project. And I like to call that Kotlin/JVM/native. That's not super good in terms of marketing, but just I want to highlight the fact that it's not Kotlin native. Kotlin native is not using the JVM basically ecosystem. So that's very different. And I think this combination of Spring Boot plus Kotlin plus GraalVM native is pretty neat. Unlike Kotlin native, it allows to go native with the amazing JVM ecosystem, with Spring, and with all the experience that has been built on top of the JVM, because that's ultimately the JVM, a subset of the JVM plus your application compiled to a native executable, but it's still executing the OpenJDK code, basically. It performs less runtime optimization, so don't expect exactly the same level of peak performance compared to the JVM. But if you need to deploy your application and you need to start instantly your app, or if you need to have a reduced memory consumption because, for example, you are going to deploy your application in a very small instance in the cloud, that's an interesting solution. And I think there is a good thing about GraalVM native and Kotlin. It's the compiler, the Kotlin compiler infrastructure, because Kotlin has been designed also for the mobile where we have similar constraints to this native world where we really look forward to more runtime efficiency. So the compiler, the Kotlin compiler infrastructure allows, for example, via Kotlin serialization libraries to perform pretty advanced serialization to JSON, for example, without reflection involved. And like I said previously, GraalVM native support reflection, but with additional configuration and also that increase the footprint. So it's interesting to see that here, the Kotlin serialization support that is provided in Spring Boot work out of the box on this native platform. I had not a single line of additional support to add. It just worked out of the box with a very interesting and low memory footprint. So that's great. So feel free to use all your Kotlin compiler plugin-based infrastructure like Kotlin serialization with Spring Native that works super well. Another topic, so it's not yet done, but I would like to try to see later if we could collaborate with the Kotlin team on that. Currently, Spring is using this Kotlin-reflect library, which is a pretty big one. So Kotlin itself, Kotlin and the Kotlin standard library are very well optimized. They are designed to work on mobile, so it's a perfect fit with native and improving the runtime efficiency. But Kotlin Reflect is bigger. It produces important CPU and memory spikes at the startup. And so, yeah, I would like to see discussing with the Kotlin team if we could move forward on a more lightweight alternative. So not done for now, but you see the number of thumb up. Yeah, a lot of people are looking a more efficient alternative. So let's see if we can do that in the upcoming month. Also, I wanted to share just an updated point of view at Kotlin adoption. So it was a discussion we had on Twitter following a James Ward tweet. And I think the next wave of Kotlin market share increase will not necessarily come from a point of view from the better language aspect. I mean, Kotlin needs to evolve, and it's still a much better, more advanced language than Java, even Java 17. But I don't think that's enough to increase significantly more the market share, especially on server side. What I think could make the difference is the big investment made on K2 compiler that allow to compile faster. And with the upcoming new compiler front end, I think every users of Kotlin will really feel why such investment has been made in this multiple year effort. Third-party compiler plugins could really increase Kotlin market share. Currently, compiler plugins are super powerful, but the API and SPI are not stable. So it's basically only JetBrains and Google who can implement that, because in terms of maintainability, that's not possible to have that in terms of third-party compiler plugins. And if at some point it becomes more stable and that us, the community, or Spring, or you can develop your third-party compiler plugins, I think that could increase the ecosystem, the Kotlin ecosystem, and provide a lot of added value. So I hope that will be more stable shortly. Compose for the web is, to me, one of the probably the most exciting upcoming thing. So Compose is this library used on Android side to create the GUI. And JetBrains has been working on porting that on the desktop and on the web. And myself, I'm super interested into being able to develop a full stack application, both front-end and back-end, just using Kotlin, no JavaScript involved. At least not writing JavaScript. You can use JavaScript ecosystem, but you don't necessarily have to write JavaScript. And I really hope that next year we will put on Spring side more focus on building application with Spring Boot plus Kotlin at the backend with Kotlin/JVM, and using Compose for the web and the new incarnation of Kotlin.js that is much better in terms of generated JavaScript code size, much better in terms of API proposed. So yeah, there has been a lot of work by the Kotlin team underneath to improve Kotlin.js. And I think with Compose for the web, that will be a nice combination for the front end. And for the more long-term future, I'm super excited about Kotlin Rhythm. There was a very good talk by Sébastien and the team about that previously, so feel free to have a look. Yeah, so just that was just a small topic on Kotlin adoption. Recent enhancement we did on Spring Native, it's the addition of native testing. So you can now compile your code to a native executable that will then run. So that will run the same thing than running your test on the JVM, but here that will test that, for example, there is no missing reflection configuration, stuff like that. So I think that's useful from a technical point of view to validate that your application is working on native and that works to execute, for example, your Spring Boot integration tests. So you can really validate a lot of things. So yeah, that's interesting. Also, we have been working on ahead of time proxies because GraalVM Native only support JDK dynamic proxies. So JDK dynamic proxies, they are only working on top of interfaces. In Spring, proxies are used to implement the security, for example, to support this kind of add pre-authorized Spring security annotation that will protect your application. We basically check access with a proxy. Transaction management in your GPA persistence is also performed via proxies. And previously, with GraalVM Native, we were just able to support that on top of interfaces because that was supported with configuration on native platform. But proxies and classes were not supported because on the JVM, we do that by creating bytecode at runtime with CJlib library, for example, and that's not supported on native. So what we did is that we now create those proxies ahead of time during the build, and that allows us to support this kind of pattern, like using add transaction or add transactional or add pre-authorize on plain classes. So we are now going to talk about probably the most important feature that we have been working on this last month. It's ahead of time transformations, because the Spring Native journey has begun as let's fix GraalVM bugs to be able to run Spring, because Spring is using various parts of the JDK that were not originally fully mature and supported by the GraalVM team. So 2 years ago, we began to work with the GraalVM team to improve GraalVM itself. After, I think our goal was to be able to infer the related native configuration to run your Spring application. So that was the second step. And now, since we have reached some interesting result with that, we have been working on transforming your Spring application at build time in order to require less ints, so less manual configuration, and improve the compatibility and lower the memory footprint when running on native. So for that, we have introduced Spring AOT, so AOT for ahead of time plugins. That's concretely Spring AOT, Maven and Gradle plugins that perform powerful build time transformation on Spring Boot applications. And that improves the efficiency on native, but potentially on JVM too. I will share more figures later. So you have your regular Spring Boot application source code that is typically compiled with Javac and that generates your application bytecode. This is what happens typically via Spring Boot, Maven, or Gradle plugin, and that will continue to be the same. But what we are adding in Spring Native is that we are adding the Spring AOT plugin that will generate some sources ahead of time, compile them via a second phase of compilation, and generate some ahead of time bytecode and native configuration that will be basically complementary to the application bytecode. And this is what is compiled by the native image compiler, and which then creates the native executable. And during the summer, a huge effort has been done by Stefan Nicol and Brian Kozel to process Spring application context beans at build time to basically optimize the runtime behavior. And so what we do now is that when you build your application, we are going to create the Spring application context. We are not going to run it. We just create it. We analyze at build time most of the Spring Boot conditions that basically creates some part of the infrastructure if if this class or this library is on the class path, for example. So we are freezing a lot of things with closed world assumptions, and that allow to generate a programmatic application context, which is pretty optimized and allow to run faster on the JVM and also to be more compatible with native with less configuration involved. So this is basically what happens for regular Spring Boot application runtime. So you have your Spring application where you are using the run application, for example, in Kotlin to start your Spring Boot application. It's going to use ISM class reading to select very quickly what are the configurations that are useful for this Spring Boot application. Then it's going to use reflection to process your add configuration file from your application and from Spring Boot. It's also going to use reflection to read Spring factories. So Spring factories are similar to service loader. That's a plugin mechanism that is the basis of Spring Boot. And we were also, in regular Spring Boot application, we are creating cglib proxies at runtime. So that's what happened currently, and what will happen in the future without AOT being involved. But with AOT, that's different. A lot of processing has been done during the build. And so at runtime, for the plugin mechanism, we don't have to read some properties file and create stuff via reflection. We have already created a programmatic version optimized for your specific application with your class path and your properties with only the required bits that you need. We do the same for the application context. So we are going to generate at build time an optimized version of the application context specifically crafted for your Spring application. And you see that it's not using reflection, it's using programmatic constructs, so lambdas, method references, etc. No reflection involved, so it's by default compatible with native. And so that's allowed to go to lower the footprint and improve the compatibility. So the goal is not to remove reflection because we are still using reflection. It's more to move reflection from runtime to build time for the configuration part. For the add controller, add component, add services, it will still happen at runtime. But here the critical part was really the configuration bits. The goal is also to reduce the amount of Spring infrastructure required at runtime. The goal is also to use the Maven and Gradle plugins with source generation. And we did that, and we did not use, for example, annotation processors because they were too limited for our needs. And if you have followed my work around Spring Foo, Kofu, DSLs, etc., there is two things in Spring Foo where I explored with the community how to write Spring application in a more functional way using Kotlin DSL. So I still believe in the potential of those Kotlin DSL, and a few of them are directly integrated in Spring Boot and Spring Framework and Spring Security. So that's still perfectly fine. But what is interesting here is that we bring the level of efficiency that was achievable by using a different way to write your Spring application to regular Spring Boot application, because what we do at build time is that we transform your regular Spring Boot application into a Spring Foo-like application. So it's basically, in terms of memory footprint, startup time, it's basically much closer to what you have with Kofu, if you are using that, than what you have with actual Spring Boot application. So there is a part of Spring Foo that live behind that work, even if that's not very visible from the point of view of the user. So this AOT mode, it's important to understand that for the JVM, it's optional. So you have to enable it via a flag here, java-d spring AOT equals true. It's optional because it really brings new constraints. So while with the regular mode, everything can be dynamic, you can have your Spring Cloud config server that will bring some configuration at runtime, and everything is super dynamic. AOT will freeze a big part of the infrastructure. So that may be a good fit for some people who want more efficient application. Maybe that will be not a good fit for some others. So here in Spring Native, AOT mode on the JVM is optional. But it is mandatory on native because for native, we require AOT mode to be able to generate the native configuration and to freeze more stuff at build time. And really, native is really built on this closed world assumption. So we think this is a good trade-off. So concrete data points. So here is the build time of 3 applications. Command line runner is really almost empty Spring Boot application with just something printed on the command line. WebMVC Tomcat is Spring MVC plus Spring Boot plus Tomcat plus Jackson with simple REST endpoints. And Pet Clinic JDBC is the Spring Data JDBC-based flavor of our famous Pet Clinic application. So something that is close to a real-life application, I would say. So on the JVM, the build is super fast, a few seconds. On native, so native 0.10 is our current last released version. So you see that between 1 to 3 minutes to build. And you see that with the upcoming .11 release, we have done a significant improvement in terms of reducing the build time, and even more by using GraalVM 21.3. So native is not going to compile super mega fast close to the JVM in the foreseeable future, but by combining improvement on Spring side and on GraalVM side, you can expect that the build time will be reduced in the future. Container image size. So it's not the most important metric from my point of view. I'm much more interested by memory consumption, but since everybody likes to compare their container image size, let's do that. So with the JVM here, I think we have optimized that in Spring Boot 2.6 and using a smaller based operating system, but it's the figures with 2.5 from a few months. You see that we are around 200 megabytes for your container image that will contain the operating system, the JVM, and your application. For native.10, you see that we are really using a small OS layer and just a native executable. So you see that's much smaller. So we are significantly smaller. And with native .11 snapshots, we are close to that. But there is a new feature in native .11, which is support for UPX compression. So UPX is a very powerful compression mechanism algorithm, and we allow to compress your container image with that, and that allows to have, for example, a container image with the operating system and your native executable with everything included in less than 50 megabytes. So I think that's pretty interesting. And even if UPX is compressing that, so at runtime you need to decompress, the fact that you require less I/O will make your application start even faster. So that's an interesting use case where something that you have to decompress at startup is going to start faster than the original version because there is less I/O involved. If we go deeper in the related minimal native container image, you will see that we have a very small base layer of 17 megabytes. So it's a subset of Ubuntu distribution with only glibc, OpenSSL libs, etc. On top of that, you have 15 megabytes native executable that contain the code of the Spring MVC plus Spring Boot application, the subset of the JVM that is used, Jackson, your REST endpoint, etc. So that's a pretty optimized and interesting. And here this is a version compressed via UPX. Memory footprint. So I think that's a super interesting metric. So with the JVM, we have this kind of figures. I did the measurement on Mac that really change on the various across the various platforms. You see that by using ahead of time transformation on your regular JVM application, you will gain average 10%. So that's interesting because we did not any optimization for the JVM. Our work is really focused on native, but by using the ahead of time transformation that has been designed for native, without any JVM specific optimization, we have already a 10% gain, which is kind of interesting in terms of memory footprint. So here, this is the RSS memory, so the total amount of memory consumed by the process, it is not just the heap. And you see that with native, already with native.10, we were significantly below in terms of memory consumption after startup. And with native.11, we have around 20% of footprint reduction, which is pretty huge, I think. So it's interesting to see that we continue to optimize our native support to go smaller, and we have not finished to optimize this thing. Startup time here, I think that's a no-brainer. Native is the clear winner. Instant startup, so with Pet Clinic and our latest .11 upcoming release, we are starting Pet Clinic JDBC in less than 50 milliseconds. So that's pretty impressive. So let's talk about the roadmap, and then we will be able to maybe talk about your questions. So in terms of little focus on enterprise support, so we have at VMware, we have a support agreement in place with Bellsoft in order to provide end-to-end support for this native platform. That means that Bellsoft is providing some support in collaboration via VMware Tanzu for the JVM side. We are leveraging Bellsoft Libericanik, which is a distribution of GraalVM Community Edition, to provide native support end-to-end. So I think that's pretty important for some companies. Now on the open source side, the next release that we are really working on that for many months. So that's our big focus, is this upcoming Spring Native .11 release. Key feature are ahead of time application context creation. So this is the big work that we are doing for many months. Leveraging GraalVM 21.3, which has been released a few days ago, and it provides some interesting reflection optimization. So basically with GraalVM 21.3, using reflection is less costly in terms of memory footprint. It provides both Java 11 and Java 17 support. We are going to stop supporting Java 8 because basically GraalVM 21.3 doesn't provide a Java 8 specific build. You can still compile your Java 8 bytecode with the Java 11 or Java 17 support, but there is no dedicated distribution because that's not easy to support on the GraalVM side. So if you are using Kotlin, I mean, you are fine. You can create whatever, you can generate whatever level of bytecode you need from Java 11 to Java 17, which is supported with Kotlin 1.6, and you should be fine. It will be based on Spring Boot 2.6 to be released mid-November. And it will provide you the UPX compression that allows to achieve a 5x compression ratio. So the first milestone of .11 is already available, so we can try it. Be aware that there is no testing support yet, and it is still based on GraalVM 21.2. .11 M2 will be released in a few days. It will be based on GraalVM 21.3 and will provide testing support, hopefully. And .11 will be .11.0 should be released late November following Spring Boot 2.6 release. So this is a version that will provide a pretty optimized footprint and a whole new ahead of time engine. But there won't be any Spring Native .12 or .13. In fact, the future of Spring Native is first-class native support in Spring Boot 3. And that means that instead of continuing releasing Spring Native minor versions or reaching a point where Spring Native is 1.0, that won't happen. Instead, Spring Native itself will remain in beta status. And we are currently moving the native support directly supported in Spring Boot 3 out of the box. And I think that's good news for a lot of reasons, because that will allow us to reach a new level of compatibility and footprint, because until now, all we did in Spring Native to support the native platform was done without big changes on framework and boot. It was really very, very small modification. Starting now, we are going to do deep architectural changes in Spring Boot and Spring Framework to reach lower memory footprints and especially a much bigger and better compatibility with all the part of the Spring ecosystem. So I'm pretty excited about that and looking forward where we will land with that. So the architecture will likely change, but just to give you some idea about what we are going to do. So first, we have announced a roadmap towards Spring Framework 6 GA. So milestone 1 of Spring Framework is expected later this year. And the GA of Spring Framework 6 will be released Q4 2022 with Spring Boot 3 GA to follow a little bit after. And we will provide a migration path from using Spring Boot 2.x with Spring Native to Spring Boot 3. But really, this is going to use the same basis. So if you are using a Spring Native or plan to use Spring Native in the upcoming months, you are perfectly fine. You are just going to leverage an improved version, better integrated with Spring Boot 3. And the goals are seamless integration in Spring Boot. For example, we plan to integrate native support directly in Spring Boot, Gradle, and Maven plugins. So instead of having a lot of other plugins like Spring IoT plugins, everything should be more integrated with Spring Boot out of the box. The native support will be better, better runtime efficiency, and the IoT engine will be basically integrated at Spring Framework 6 level, while the native support will be more on the Spring Boot 3 side. And we have also some other parts like the native build pack support, GraalVM 22.x that we are going to use. And we have some collaboration with the GraalVM team to build some native configuration repository and libraries. But yeah, no need to go deeper on that topic. So with Spring Boot 3 and Spring Framework 6, we are building a framework for the next decade, and we are doing a lot of changes like using Java 17 bytecode as the minimal version. So with a new version of Kotlin that will work perfectly fine. And Spring Boot 3 IoT optimization and native support will benefit to millions of Spring Boot applications. So if currently you are developing with Kotlin a Spring Boot application with Spring Boot 2.4, 2.5, for example, our goal is to make it easy for you to just trigger the native build, and with Spring Boot 3 to just ship that as a native executable. With Spring Native, I think we are in the middle of the road, and we will finish to mature that and ship that into Spring Boot 3 with native support out of the box. Okay, I think I'm done with the slides. So maybe Anton, we can see if there is some questions.
Sure, there are some in the chat, but first I wanted to say that I've been using Spring since 2004, and the framework still continues to innovate at an immense speed, and that's a huge effort that I can see here. And
yeah,
well,
and
thank you, team, for continuing building up with the new technologies.
Yeah, and I think what is difficult, that's maybe the most difficult thing that we are doing. We try to innovate, and we try to do that without breaking your applications. And I think maybe on your side, the Cater team, or on the Kotlin side, it's super difficult to do such huge changes underneath without breaking anything. So maybe with the Kotlin compiler plugins, you have Kotlin compiler work, you have some challenges like that. So yeah, we try to innovate, but we try. So for example, we are going to use Java 17 minimum bytecode, this native support IoT stuff, but we want to reduce the breaking changes. So I don't say we will support 100% of Spring Boot 2 application without any changes with Spring Boot 3 and this IoT native work, but really that will be minimal modifications, mainly build configuration update, and yeah, we will try to provide new capabilities without breaking your apps, because we know that you have other stuff to do.
right? So just to reiterate, so we have Spring the framework, where we have all the APIs, where we write the application code with those APIs, basically the framework that we all know and love. Then we have this Spring AOT that is actually a build plugin, right? That
Yeah,
creates all kind of pre-configured bean definitions, like eliminates the needless calls for loading something, reading the configuration files, eliminating unnecessary reflection calls, and so on. And then we have Spring Native, which is more like a infrastructure, right, to get the
yeah.
final native image, right?
Yeah. So what could be confusing for people is that Spring AOT plugins has grown inside the Spring Native effort, even if they have a wider scope because they can be used on JVM side. So that's the weird thing that will be solved with the new infrastructure. So basically, if you go to the Spring Native repository, you will see that there is some Spring-Native-modules, but there is some Spring AOT modules as well. And the Spring AOT side really transform your application without much native stuff involved. There is just small plugins that will generate the native configuration. So it's just native configuration inference. And this is basically, so it's not, there is the ongoing work, so it's not done yet fully, but it should be conceptually a Spring Framework module that will be directly, so the engine will be a module, but it should be consumed via Spring Boot plugins because we need something that is invoked. We need something opinionated that is involved at build time. And so Spring Boot, Maven, and Gradle plugins will likely be able to call this AOT engine to perform optimizations on your Spring Boot application in order to serve this optimized version. Optionally, you will be able to generate the native configuration or not. Basically, that will allow to run faster on the JVM and to provide native support out of the box. So yeah, currently that's why we want to move the various bits at the right place in Spring Boot 3 and Spring Framework 6 and the related portfolio project.
I see. So in theory, if I can't use GraalVM native image, but I still have to run on the JVM, optionally I can pre-build my Spring application with Spring AOT and get some optimizations, like benefits out of this, right?
Yeah, you can. Basically, you are taking some shortcut because at build time, you are going to say, okay, my class path is fixed, so I'm not going to evaluate the class path conditions. I'm going to fix those parameters, those properties, but maybe keep a few ones that could be dynamic at runtime. And so, yeah, those kind of optimizations are interesting because basically we are, I was speaking about the Spring Foo project where we have those nice DSL to configure your Spring application, but that's not the regular flavor of Spring Boot application. And an outcome of that Spring Foo project is that Spring application were running faster, consuming less memory and starting faster and providing better native compatibility. So the spirit of what we did is to transform the annotation configuration to something which is programmatic, using Lambda, using less reflection. And basically, that's using the same kind of functional Spring API that Spring Foo are using. But we do that at build time for any kind of Spring Boot application. Just you can imagine that that's a big effort. But that's we have done with this .11 release that we are going to release late November.
And the closed world assumption is pretty valid on the JVM, even without native image, right? Because a lot of people are actually building fat jars and they are not changing the class path or anything.
It's interesting to, if we think about it, I think this closed world assumption, so really native image, GraalVM native image is going super deep on this closed world assumption because that's basically the basis of the GraalVM static analysis. So everything is super frozen. So that's really a key architectural point bring by the GraalVM native image. But before that, when Spring Boot was introduced and we were switching from this deploy UR on application server to let's deploy just a jar executable that contains Tomcat or Netty with Spring Boot 1.0, that's really where by default most of the users are using closed world assumption. some people still deploy additional MySQL driver, for example, for their databases, but I think most people are really using closed world assumptions. So here we are just taking advantage of that deployment model in a more involved way.
Right. So let's get to the questions. We have some of them in the chat. Orlando was asking if there is any analysis done for the comparison between Spring Native, Micronaut, or Quarkus. I assume there is none because Spring Native is still a work in progress, and Micronaut and Quarkus have been there for some time already. But maybe you have been comparing something.
Yeah, so it's either, so it all depends how you benchmark things. Sometimes it's a little bit controversial, and also it's moving fast. Like I said, .11 is providing 20% improvement. There was some native configuration fixes which reduces the memory consumption of 40 megabytes just by a single line of configuration. So I think we take the time to have the design right. Also, we collaborate closely with the GraalVM team to find the good trade-off between compatibility and footprint, because there is a big compatibility challenge related to, for example, build time, class initialization, or some other controversial topics. So we are working on that, and I think the community will share some. There will be some benchmark. I think the GraalVM team is going to provide in sometimes this kind of benchmark in a kind of neutral way. So you will be able to compare that. But yeah, like I said, what we did with Spring Native, I think we did already some big improvements in terms of footprint. We did that without modifying Spring Boot and Spring Framework. So really, I think we have been pretty far with that big constraint. And basically, the final mark in terms of figures will be what we will provide for .11. So we will provide updated figures with .11. And then the second part of the work is going to begin. It's, okay, let's modify Spring Boot and Spring Framework architecture in order to go the next step. And yeah, I can't say where we will land, just saying that all what we did until now was without significant modification in Spring Boot and Spring Framework code base. I think that will increase very significantly the compatibility, and that will increase also the footprint. But yeah, I'm not sure how much, so we will see.
Okay. There is a question by Anbu about Spring Foo, if it will become a mainline in Spring 6.
Mm-hmm. So I had to. So I'm leading the Spring Native effort. I'm working on the Kotlin support in Spring Framework, and I had to choose at some point about where I put my time and energy. So, like I said, there is two parts conceptually in Spring Foo. There is these DSLs, and a lot of DSLs are directly integrated and available in Spring Framework. So the web DSLs, the Beans one. Spring Security provide out-of-the-box Kotlin DSL. It's provided by Spring Security, and just Spring Foo was providing the glue, so the Spring Boot part of the DSL. That part, currently, I had to stop working on that, not because I don't believe in it, but because I need to focus on the strategical topics, and yeah, I don't want to work during the night. So basically, but the other part of Spring Foo, which is the optimized footprint, and leveraging more the functional bin configuration to provide better efficiency, less configuration. That's basically at the heart of what we did in the AOT work. And so I think, yeah, a part of Spring Foo is going to go GA via the efficiency improvements, and that will impact all Spring Boot applications, including those who are built with regular Spring Boot annotations and Spring annotations in general. And for the DSL part at Spring Boot level, so applications, the DSL part, which is not included in Framework or Security, there is no plan currently to integrate that in Spring Framework 6 on Spring Boot 3. But when Spring Boot 3 will be released, I think I will work engaged on that project with other members of the community to see how we can leverage those Spring functional and runtime efficiency improvements, and just add on top the DSL part and see how it goes. But the DSL side of Spring Foo, will remain experimental, and for now it's in pause mode because I don't have the time.
Right. Well, Spring Full looks like a perfect incubator for the new features, and we see them migrating into the main line and improving the overall experience. So that's great.
That's what we had, for example, for coroutines. Coroutines started their live in Spring Full, and then coroutine support is integrated in Spring Framework. Same for this runtime efficiency topic. And I think, we will continue to experiment on that side.
All right. The next question is, can we build a Spring Native with Kotlin project for Apple Silicon?
Good question. So this is not on our side; it is on GraalVM side. There is an issue about Apple Silicon support. There is underneath. So Arch64, the underlying architecture, is supported by GraalVM, but I think they are missing some bits like the JVM distribution, JVM CI that they are using. So Labs GDK, the GDK that they are using, they have not the build for Apple Silicon. So I think it's mostly some integration work and some infrastructure to get the CI machine to build that thing. But I think they recently commented to say that they will move forward. So no support right now. I hope that in the future that will arrive, and they shared some intention to provide that later. I can't say if that will be next month or next year or in 3 years, but they plan to move on that clearly. And for now, it's working with the Rosetta translation thing. So you can basically it works in compatibility mode, and I hope it will provide native support for Apple Silicon maybe next year. I hope.
Yep. Let's take another 2 questions, and then we are out of time, I think. There is like a small question about Kofui again. If any samples are available for a Spring Batch. I guess it's not really about Kofu, but rather about DSL for Spring Batch.
Yeah, I'm not sure about DSL about Spring Batch. I will maybe ask to the team. I don't think we have something yet, at least. But that's every Spring project can provide a nice DSL like the Spring Security team provided. I think for Spring Security, it had more people. There was more people asking, but typically, I think that would make sense. And I don't remember if we have it. Maybe we have a peer. Honestly, I don't remember. Need to check.
The cool part is that with the extension functions, you can tailor your own DSL for the specific module, like you said, for Spring Security. Or I really like what has been done with JDBC operations, like for JDBC templates, where you have exchange the order of the parameters to make the use of the API more idiomatic to Kotlin developers. And let's take the last question, I think.
Just maybe just add over. So what you said is very interesting. So for Spring Batch, if you want to have a look to what has been done in Spring Security and apply the same kind of pattern to Spring Batch, I think that's a good pattern.
Right. So let's take the last question, I think, and just a general question, whether Spring Native, what is the status of it? When is going to be finalized? Because probably someone just missed it, and
no problem. And that's the most important point. So I'm happy to repeat it and clarify it. So we are going to. So currently, the latest release version is Spring Native.10 based on Spring Boot 2.5. We are going to release late November Spring Native.11 that will provide this new IoT engine that basically create an optimized application context with functional APIs and reduce the footprint by average of 20% and greatly improve the compatibility for various patterns. So it will be released late November, and that will be the last minor release of Spring Native. After that, you will consume the native support directly via Spring Boot 3. So it's not decided yet, but I guess you will consume some Spring Boot 3 milestones that will provide native support during next year. And then at the end of the year, like I said, we are going to release Spring Framework 6, and after that, Spring Boot 3. That will provide the native support in a GA/production ready fashion. And people are already using Spring Native in production right now. Just we want to, Native is a very young platform, and we want to take the time to mature it correctly to provide the level of quality that Spring developers usually expect from Spring. And so we want to take the time to provide it in a fully GA mode. So Native will be supported out of the box in Spring Boot 3 towards end of next year.
Right. So we have to wrap it up. There was one more question, but I think we need to wrap up here, and probably we'll just answer it a bit later. So thank you, Sébastien, for the presentation. Kudos for the huge work you are doing at Spring team, and well, good luck with the development.
Thanks, and that's a team-wide effort. So really, all the Spring team is now involved in that, and yeah, we are many working on that. So yeah, thanks a lot, and looking forward what we will provide in .11 and Spring Boot 3 native support.
Right.
Cheers.
Bye bye.